Hello everybody and welcome to Video Diary 7 for my Open Ocarina video diary series. This is my favorite video that I've done. The content is the one I'm the most excited about, and I will explain why in just a second. But first I want to talk to you about, I guess, why we're doing the topic of this video, which is Link's height. And that is because I decided to take a quick break from working on, or not really a break, I haven't really started yet, but I haven't dived into making the mega map that is the core of the Open Ocarina project. And I decided, because of my last video project steps, I decided that I would rather insert Link into Unreal and play around with him specifically, as opposed to the basic Unreal mannequin, which was present in the previous video. And so in order to do this, the first step is that I had to actually figure out what young Link's proportions are, what everything's proportions are, because when importing stuff into Unreal, well, also into Blender, but basically, if you saw earlier on, the system that I used to rip the models from Ocarina of Time, those models, I don't know if, like, it's a translation issue or if, like, just the scaling data is way off, but basically it comes out hundreds of times bigger than it's supposed to. And it's not, like, an exact thing. It's not like, oh, this is 10 times bigger, or this is what, and so I need to figure out exactly how big the models are, how big the rips are, in general, to then figure out how much I need to shrink them by in order to make them quote unquote properly sized. And so I needed to kind of do this whole detour mostly it was trial and error, but I needed to figure out just how much bigger these meshes were importing so that I could set up a proper workflow for getting them into the correct size. And then once I have everything in on the correct size, I can know what to scale young Link to, because I need young Link's height in order to have him be present in the base game as the main model. Obviously, it does. I mean, I guess I could have 6 foot tall young Link while I do this, but that's not really obviously what is going to work. And if young Link is the wrong size, then everything else based around him is also going to be the wrong size. So I need to get everything to the correct scale, but most importantly, young Link, because I'm trying to get him into the Unreal Engine as a playable character, more or less. Not fully playable. I'm only going to have him run an idle. But the thing that gets me the most excited, the reason I'm super excited about this, is because I tried to find his height online, and I got to the conclusion that no one has actually done this before. There are a lot of estimates about how tall young Link is. There is at least one other person that tried to use some data-driven thing to get the answer, but as far as I can tell, I am the first person on the internet to use actual game assets and actual, like, math to figure out the actual height for young Link, and that's why I'm so excited about this video. As far as I can see, I'm the very first person to do this, which just has me jazzed. This video is about how I went through that process. So, to start, I need to measure against something that I actually already know the size of in order to get young Link's height. I started with trying to do this with the Master Sword because it's an object that both he and adult Link stand next to. I guess I could have also used the Hylian Shield. The issue with both of these is that I don't actually know the size of them either, as far as I can tell. My Hyrule Historia is in storage right now, so I couldn't whip that out. I couldn't find anything on the internet for the size of them. And then for the Master Sword specifically, the animations don't exactly line up in such a way that it's easy to say, like, oh, at this point, young Link standing at 100% of his height. Also, for the Master Sword, it's buried inside the little pedestal thing, so I never actually see it fully against young Link properly. So the next thing I had to do in order to do this was find something I did know the size of, and it turns out that that thing is adult Link. There are actually really good estimates for adult Link's height on the internet. A lot of people use the little dive meter thing in the laboratory at the lake as a reference for what his height is. This isn't fully accurate though, because the meter itself is just a texture and it's not lined up perfectly. It shows him at around 170 centimeters. But it actually gives him about 10 centimeters more than it needs to. Someone else went through and found the height when comparing Link's size to Ganon. This is the same person that got close to young Link's size, but kind of missed it earlier on. But essentially, Hyrule Historia does say that Ganon is canonically 230 centimeters tall. He's 2.3 meters tall. And so since we know Ganon's height, we can measure proportionally what Link's height is in comparison to that. And when I say we, I mean someone on DeviantArt already did it. So Link's height is 160 centimeters or 5'3". There's some question about this. Maybe he's 163. Some people kind of generally assume between 160 and 170. But I think that as far as I can tell, 160 is the best measurement to go off of. So adult Link is 5'3". He's kind of short. Like even just for an adult, he's kind of short. So the next step is I need to figure out what young Link's height is. And so in order to do that, I now needed to take the height that I knew, adult Link's, and get it into Unreal proportionally, because we need to do two conversions here. The first one is actually importing the mesh into Blender, which comes out way too big. But then from there, I need to know what to scale it against. Blender does have a measuring tool that I could use, but I decided to just measure it in the game engine itself, because that's the thing where the ultimate truth has to come through. So like if Blender thinks Link is 1 meter 0.6, and Unreal takes that 1 meter 0.6 and goes, oh, cool, I see you have, 160 meter guy. Like, it doesn't really matter. So go into Unreal, and Unreal has this handy little tool where you can align people against, I don't know if it's a tool, but it's a view. You can align people against a graph, and Unreal uses centimeters as its base unit. So in the graph view, they have these bigger squares that are made up of 10 centimeters, so 1 decimeter, and obviously 10 of those is a meter. So using that, I can see how tall the Unreal mannequin is, with a little bit of variation because he has his knees bent. But overall, I got to the number of the Unreal mannequin being about 180 centimeters. So the next thing I need to do is import a view of Link, of an adult Link, get a scene with adult Link in it, and scale it down just by trial and error until adult Link is 160 centimeters to the Unreal mannequin's 180. So before I did any kind of actual scaling, I just took the mesh in as imported to Blender and put it into Unreal, and it came out super massive. But you'll also notice in this video there's another issue, and that's that everything is inside out. It looks kind of funny because you can still see some walls, and the reason that this is happening is that all the game assets, like most game assets actually, are considered one-sided. So one side has like a texture, it has data properties, and the other side is just invisible. It clips entirely through. There's no data there. There's no reference there. That's why when you play old games, if you move the camera, you can see like right through the wall into the world behind it until you're looking at something that has its proper view faced to it. It's to save on a lot of data and a lot of processing. Modern games do this too. We're just a lot better at being able to keep the camera inbound so you don't really see it. But in theory, if you were to position a camera out of, well, I mean, like you see it in glitch videos, whenever someone falls through the map, everything kind of becomes weirdly invisible, or like certain things become see-through. Basically, anything you're seeing the inside of or the behind of that isn't meant to be seen won't have any data and will just be completely transparent. Now, with this case, what's happening is everything is inside out. So we're seeing the inside folds for everything, but not necessarily outside folds. So on top of scaling everything, I now know that I need to I need to flip it inside out, and that's easy enough. I just scale it into a negative size, like when you're in like a photo editing thing and you drag something to squish it all the way down, and then you pull across the other way, and then it becomes big again. Exact same process. So, got a scale link. We need to fold him inside out and then scale him. And then, like I said, this is just a bunch of trial and error. I scaled him down a little bit and then imported him into Unreal, and then walk the Unreal mannequin up to Link to just get a sense of if he seems like he's about 20 centimeters or 2/3 of a foot shorter than him, and then kind of get that right until I get within the margin of error enough that it's worthwhile to start just actually measuring adult Link. And you'll also notice right here in this clip, when I import this scene, even though everything's right side in, not inside out, right side in is the opposite of inside, whatever. He is no longer inside out. And if you take a look, I can't actually get my Unreal guy in there, and that's because I forgot to give it boundaries. Right now, the whole object just has one boundary. Or one bounding box or collision box. So what I need to do is quickly go in there and basically say like every surface is its own collision box, which in modern games is kind of dumb because you don't need that much level of detail. You don't need like the curve of a tip of a finger to have one-to-one bounding. That costs a lot in CPU. You can just have like a cylinder be in place of that finger and get the same effects. Or for some objects, you know, it's like, though there's a round cup, but clearly it has like a cube bounding box. But because everything's so simple in Ocarina of Time and there's so few polygons in general, the weight penalty for not mapping out everything with its own collision is negligible. So it's easier, and I think just like in the spirit of the project, to just say like anything that is a polygon, it can't get passed through. So once I've done this, I now can run my Unreal guy up next to Link and see that Link is a little too big, but I can still take a moment and actually measure Link and see how much he's too big by, and then go into Blender, scale him again, and then repeat this again and again and again until I have my measurements, which turned out to be, I think, like 0. I needed to scale it down to 0.015 of its original scale to get it to be scaled properly. And that's what with those measurements, I was able to get adult Link down to 160 centimeters properly. And so now I can apply that scale down to a scene that has young Link in it, like his house. Delete everything that's not the house. Import that young Link model scaled down into Unreal. And boom, we have a 2-scale young Link. And so for the moment of triumph, at 160 centimeters to adult Link, young Link is 113 centimeters tall. He is 3'8", or I guess that's a little bit closer to 3'8.5. Imperial is a dumb measurement, but this is the first time on the internet we have actual accurate young Link's height, and it was because of me. So I'll see you all next time. This has been fun.